Can you tell me what is the definition of a circle? Well, we take up this set of points we are referring to in a plane only, xy plane, right? Locus. So these days we do not talk about locus, we talk of set of points. Set of points which are at a constant distance, at a fixed distance, at a constant distance from a fixed point, from a fixed point. Those set of points form a curve called circle. Can understand? That's right. The circle, they fix the set of points. You see, all those points, for example, suppose I have drawn a circle over here. This is the center. This is the center. O is the center, and these are the set of points which form. These are the points on the circle are at a constant distance from O, at the uniform distance from O, and they form a set of points. Right? I hope you understand this. Take any point here, that will be the same distance from this, of course, in a plane. Now we talk about that, say. That's right. Welcome. Right. So we talk about the set of points having a particular property. That is what is called locus. Set of points having a particular property in anywhere in certain condition is called a locus. So the locus of point, that is also an alternate definition, locus of a point which moves such a distance that it has a constant. Well, locus, as I told you, locus is what? Same set of points, clear, having a fixed property. Now that was first. Now second point is, what do we need? We need two things. We need center, which is a fixed point, and we need radius, that is the fixed distance. This is what I told you over here. These are the two things, that is constant distance from a fixed point. That fixed point is called center. Fixed point is called the center, and this constant distance is called the radius. Suppose center is say we talk about now, center is at hk. These are the coordinates of a point, and radius is a. So therefore this center is at hk. Let's take up any point p xy. Xy is a variable point which gives you, that's right, Kashish, welcome. Xy is the point which builds this locus. We say let pxy be any point on the circle. This point is called what? This point is this is called the set builder. This point is called set builder, which builds the set, which builds the locus. And therefore we talk about that this is the center hk, and this is the distance. Therefore the distance will be x minus h whole square plus y minus k whole square will be equal to a square or r square, whatever you may take up. This becomes the equation of the circle. Right. After discussing the equation of the circle, we talk about its properties. What is the nature of this equation? Nature of the equation of the circle. Can you tell me what are the conditions for the equation to become a circle? What are the conditions? Yes, conditions. If we understand this, equation becomes, if we simplify, it should be x square plus y square minus 2hxy x minus 2yk plus h square plus k square minus a square equal to 0. Well, we don't call it quadratic. We don't call it quadratic. We call it second degree equation in x and y. I'll tell you, I'll come to that. Tomorrow I'll take up that point very quickly. What is the nature here? It has characteristics as, number one, it is second degree equation. Second degree equation in x and y. Number two, that's right, it is second degree equation in x and y. Number two, there is no term containing xy. No term containing xy. I'll tell you why later, quickly. Number three is that generally coefficient of x square is equal to coefficient of y square. Now, to be very particular about it, that's right, you are right, Anuj, you are very much right, because the general second degree equation, I must tell you here, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 is a general second degree equation. Is a general second degree equation. Now, which can represent many things that we will discuss later. But it can represent what? It can represent a circle only. It can represent a circle only if a is equal to b, h is equal to 0. It can be a circle only if a is equal to b and h is equal to 0. Then it will represent a circle. Right. So we come to, that means the equation, therefore, if you put a equal to b, let a equal to b equal to 1. Then this equation becomes, the general second degree equation becomes, general equation of circle becomes what? Becomes x square plus y square plus 2gx plus 2fy plus c equal to 0. If not equal, then it will not represent a circle. It may represent a parabola. It may it may represent, it will not represent, it will be either conic, it will be a parabola, ellipse or hyperbola, or it may represent a pair of lines as well. It may represent a pair of lines as well. Right? So we have discussed, this is the general equation, x square plus y square plus 2gx plus 2fy plus c equal to 0 will be a general second degree equation which will represent what? Which will represent a circle. Right. We talk about another thing now. Fourth. Now if x square plus y square plus 2gx plus 2fy plus c equal to 0 is given to be a circle, we are now trying to find out what will be its center. What will be its center and radius? It can be done as, that's right, see now what we do. No, that's fine, that's fine. Anuj, you are very much right, because it can be written as x plus g whole square plus y plus f whole square equal to g square plus f square minus c, which can be written as x minus minus g whole square plus y minus minus f whole square is equal to under root of g square plus f square minus c whole square. Right. Compare it with, now you compare it with our known equation x minus h whole square plus y minus k whole square equal to a square. What do you find now? What do you find? You find h is equal to minus g. That means center is equal to minus g minus f, and radius is equal to what? Radius is equal to under root of g square plus f square minus c. Please understand it. It will, that's right, square root of g square plus f square minus c, that's right, that becomes the radius. Okay. Now after doing this, you must note that one condition that we impose over here, that is, now look here, g square plus f square minus c should be positive. Should be positive. Then it represents a circle. Then it represents a circle. Now if g square plus f square minus c is equal to 0, can you tell me what should happen? That's right, it will become a circle with 0 radius. That is called point circle. Very good. Point circle. Now if g square plus f square minus c is less than 0, what happens? Yes, it becomes a virtual circle, we call it. Virtual or imaginary circle. Virtual circle. It is not in reality a circle at all. That is what was our point here. Point 4th. We come to 5th point now. Now what can be the equation of a circle? Equation of a circle where 2 points, 2 endpoints of a diameter are given. There are many diameters of a circle. One diameter is given. That means what happens here? We have a circle over here, and we have a diameter here, and then what we have this is point x1 y1, and this point is x2 y2. These are the endpoints of a diameter. Yes, that's right, that's absolutely right. What do? If I take up any point pxy on the circle, join PA, join PB. You know angle in a semicircle is a right angle. Angle in a semicircle is right angle. Therefore you can say that slope of PA into slope of PB, they are perpendicular lines, is equal to -1. And slope of PA becomes y minus y1 upon x minus x1 into y minus y2 upon x minus x2 becomes -1. And that leads to the equation of the circle as x minus x1 into x minus x2 plus y minus y1 into y minus y2 equal to 0. This gives you the equation of the circle. We call it equation of the circle in diameter form. Diameter form of the equation of the circle. Clear? So this is how we find the equation of a circle. Then we take up another point here. Sixth, parametric form. Parametric form of an equation of a circle. What do we mean by parametric form? That is, you have a circle over here. We have this is x-axis and y-axis. This is OX and this is Y. The center here is, say, HK. This is the center. Coordinates of C. What we do here, that's right, what we do here, we draw this perpendicular over here on x-axis and take this point to be equal to like this. Like this. Like this. Okay. See now how we form this is PXY. Suppose this angle is theta and radius is A. Suppose this is, you know that this distance is equal to H. That's right. This distance is equal to X. Right? So we have this to be R. Can you tell me what is CR equal to? CR is equal to A cos theta and PR is equal to A sin theta in that right angle triangle. That's right, absolutely right. That's right. So what will be X equal to? X will be equal to H plus CR. If I take up this to be L, this to be M, so OM is equal to X, OM is equal to X is equal to OL plus CR, and this will be equal to CR here. That will be equal to H plus A cos theta. That is, X is equal to H plus A cos theta. Now similarly, this is X. Now I take up Y. You know that PM is equal to Y and PR is equal to A sin theta and RM is equal to CL is equal to K. Right. Therefore we get PM is equal to, that is, RM plus PR, that is equal to Y is equal to K plus A sin theta. So then we take up these two together. These two together, what do we get? We get X equal to H plus A cos theta and Y equal to K plus A sin theta. Together, this is called parametric form. So we get this as the parametric form of an equation of a circle. Right. We come to another thing. Can you tell me how to find? We have found this equation as a parametric form. We take up next how to find the equation with three things given. Equation of a circle given at least three things. Three things given. Say 3 points are given. 3 points are given, or you may given the equation of the diameter is given and 2 points are given. Such questions can be asked there. See how I take up. Now see how we do it. To find the equation, Let's find out. See now, we find the equation of a circle through 3 points. Through 3 points. Suppose the points are A0, 0B and origin 0, 0. How do we do it? We say let the equation be x square plus y square plus 2gx plus 2fy plus c equal to 0. Right. First it passes through 0, 0. Yes, it passes through 0, 0. That gives you what? C equal to 0. It passes through A0. What do you get? You get A square plus 2GA plus C equal to 0. I have substituted Y. But C is 0. But C is 0. That means A square plus 2 into G into A is equal to 0. That gives you 2G equal to minus A. Similarly, it passes through 0B. That gives you what? B square plus 2FB plus C equal to 0. And C is 0. That gives you 2F is equal to minus B. What will be the equation therefore? The equation becomes what? You substitute here, substituting in the given equation, that's right. You get x square plus y square minus ax minus by equal to 0. Now, I must tell you here, we could have got this equation directly if you had a little bit of instinct over here. If you find it out that this is y-axis and this is x-axis, they are at right angles, the circle passes through, see now, circle passes through origin. Circle passes through origin. Therefore, you can write it down here. See now, it passes through origin. Right, like this. So, what do we do here? It passes through origin. It cuts this at A0. It cuts this point at B0B. If I join this and this, what is AB? Can you tell me what is AB? AB is diameter. Very good. AB is diameter. Therefore, you could have used diameter form. Diameter form of the equation is x minus a into x minus 0 plus y minus 0 into y minus b equal to 0. That could have been x square minus ax plus y square minus by equal to 0. Right? That would give you the same equation, x square plus y square minus ax minus by equal to 0. Or the third method would have been, don't you realize the middle point of A and B would have been the center of the circle? Yes, we can argue, David, see now, angle in a semicircle. What is angle in a semicircle? David, what is angle? 90 degrees. That means AB is the diameter. Okay, okay. So that comes how to find, we must have 3 given conditions. We take up one more now. We take up 8th point now. What do we mean by concentric circles? Come on, concentric circles. Yes, concentric circles are having, yes, that have the same center, correct. So if equation is, look here, if the equation is x square plus y square plus 2gx plus 2fy plus c equal to 0, right, same center. Can you tell me what is the center of this circle? Its center is minus g minus f. That comes from the coefficient of x and y. Now therefore clearly the equation with the equation of the circle with same center must have same coefficients of x and y. That is, same center is in general x square plus y square plus 2gx plus 2fy plus lambda equal to 0. That shows for any lambda can have any value. Correct. For lambda can have any value. So this is much more useful when we do questions on concentric circles. We're now talking about, for example, we have a circle with center HK and touching x-axis. Touching axis of x. Can you guess what should happen? See here, we have a circle here, and we have this touches x-axis. Now see what happens. This is O, this is x, this is y. Its coordinate center is HK. Can you tell me what is the radius? Come on. Radius of this circle is what? I will use more properly mod k, because k can be negative, not necessarily positive, but the radius is always positive. So we take up radius is k. Clear? Okay. That means this is the radius here. What will be the equation? Equation will be x minus h whole square plus y minus k whole square equal to mod k whole square, and which has no bearing and can be written as x square plus y square minus 2hx minus 2ky, because mod k square is equal to k square, and k square will cancel out. It will be plus h square equal to 0. Is that all right? I take up now same thing. What will be the circle with center HK and touching y-axis, touching x-axis of y. That's right, axis of y. Radius will be what? Radius will be mod of h. That's right, mod of h is better way of putting it. Let me put it here. Why? Reason is simple. I'll give you the reason here. Say this is what is, this is O, this is x dash, this is x. I am taking this to be HK. Don't you realize this is the radius? So here it is, h is naturally given to be negative. I have deliberately shown it like that. Therefore radius will be modulus of h. What will be the equation? Equation will be x minus h whole square plus y minus k whole square will be equal to mod h whole square, and that will be equal to h square. I hope you can get it now. That's right. So the equation is x square plus y square minus 2hx minus 2ky plus k square equal to 0. That will be the equation. We come now, what will happen? What will happen? I'm taking now 11 here. That's right. We take up 11 here. What happens when a circle touches both the axes? Touches both axes. What happens? Yes, h is equal to k. Yes, you can say mod. That's right. R is equal to mod h is equal to mod k. Clear? And can you tell me, see now, I'll tell you here, let me take up circle here. See now, I'll just take up here. Say one circle is this, the other circle is this. This is the circle. It touches both x-axis and y-axis. That's right. It's like this and it's like this. So we can say now center can be AA, it can be minus AA, it can be what? Minus A minus A. If I take up A to be positive, it can be A and minus A. That's right. So center can be plus minus A and plus minus A, and radius can be, I'm taking A to be positive, A, because A is taken to be positive in all cases. And what will be the equation? This is the diagram here. The equation can be x plus minus A whole square plus y plus minus A whole square equal to A square. Clear? 4 possible. That's right. So you get x square plus y square plus minus 2ax plus minus 2ay plus a square equal to 0. This is the equation of circle, the possible circles. Now we take up twelfth. What we want to do is, we want to find out a position of a circle. We have a circle over here, and there is a line. There is a line here, I'm talking about, suppose P is a point, external point x1, y1, and this is the equation of the circle here is x square plus y square plus 2gx plus 2fy plus c equal to 0. PT is the tangent and C is the center. We want to find out the length of the tangent. Length of the tangent. That's right. Can you tell me what is C? Center C is what? Center, that's right, that's right. Center C is minus G minus F. And what is CT? CT is the radius. That is equal to g square plus f square minus c. And we want to find out PT. PT square is equal to PC square minus CT square. That is the length of the tangent. That will be equal to x1 minus plus g whole square. That is the distance, because it is minus g minus f. So whole square plus y1 plus f whole square minus g square plus f square minus c. It is square root of this whole square. If you simplify it, it is x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Right. Can you tell me what is PT equal to? Come on. PT is equal to x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. Generally, I must tell you here, S is taken to be equation of circle, x square plus y square plus 2gx plus 2fy plus c. And S1 is taken to be equal to x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. So this is equal to under root of S1. That is the length of the tangent. Please understand this. This is the length of the tangent. Now three cases arise. Now see, I will come to that. If S1 is positive, that means PT is real. PT is real. And mind it, P is outside the circle. P is outside the circle. If S1 is 0, what happens? PT is equal to 0. That means P and T coincide, right? P lies on the circle. P lies on the circle. And if S1 is less than 0, right, inside the circle. PT is imaginary. Imaginary. Therefore, P lies inside the circle. Inside the circle. That's a very important observation. Therefore, we can find out. We can find, no, P can never be imaginary. So, Prof, P can never be imaginary. P is a point. P is a real point, x1, y1. Whatever be the value of x1, y1, P will always be a point. P can never be imaginary. Right. Please understand that. So what I was talking to you now, it was the position of a point P with respect to a given circle, with respect whether P is outside, inside, or on the circle. That depends upon by substituting the point on the equation. What if it is very negative? It's very negative. That's right. If the what? Point can be negative as well. -3, -4. Where does it lie? It lies in the third quadrant. Subbarao? Right? If point P is negative, that means -3, -2 or -3 plus 2, it will lie in the second or third quadrant. Distance, that is what we are taking. Point can never be negative. Point is never imaginary, I must tell you here. Distance can be, why did we take distance to be negative? We never take distance to be negative. We take up distance always, square root is always positive. Okay, that was 13th. We take up 13th point now. Now we take up 13th point. Now I am taking a relationship between a circle, that was circle and a point. Now we take up circle and a line. circle and a line. Again, I must tell you here, that's right. Now what we do here is we are talking about a line, relationship of a line with respect to a circle. Suppose this is a line. Another line can be this, and another line can be this. Clear? What I am talking about is that the line can intersect a circle at most 2 points. At most. That means it can be 0, it can be 1, it can be 2. 0 points means it doesn't intersect the circle. 1 point means when it is a tangent. 2 points means when it is a chord or a secant. Okay? That is what we are going to prove. Suppose I take up, look here, there are two ways of doing it. Two ways of doing it. Suppose I take up first, see now, x square plus y square equal to a square. This is a special case of a circle. Can you tell me this circle? What is the center of this circle? Yes, center of this circle is 0, 0. And the radius of this circle is equal to a. Clear? Now I take up a special line equal to y equal to mx plus c. Now first method is, we solve the two equations. That is number 1 and number 2. Solving the two equations, what do we get? We get x square plus y can be written as mx plus c whole square equal to a square. That you get x square into 1 plus m square plus 2mcx plus c square minus a square equal to 0. Clear? It gives you how many values of x? It gives you how many values of x? 2 values of x. So x1 plus x2 will be equal to minus 2mc divided by 1 plus m square, and x1 x2 will be equal to c square minus a square upon 1 plus m square. Now 3 cases arise. If x1 and x2 are real, what does that mean? If x1 and x2 are real, what happens? The line cuts the circle in 2 real points. Cuts the circle in 2 real points. Therefore, what is the line? It is a secant or a chord. It is a secant to a circle. Chord, correct. Chord or circle, correct. Now second case is if x1 is equal to x2, what happens? The line is a tangent. Tangent to the circle. And in that case discriminant will be equal to 0. That will be equal to, what will be the discriminant? Right, what will be discriminant? 4m square c square minus 4 times 1 plus m square into c square minus a square is equal to 0. That's right. We'll check it up now. M square c square minus c square minus c square m square plus a square m square equal to 0. That gives you this, and this will cancel out. You get c square is equal to a square times 1 plus m square. Correct? That means c can be equal to plus minus a root of 1 plus m square. This is the condition for the line to become the tangent. And the last case, if x1 and x2 roots are imaginary, what can you say? Yes, the line does not intersect. It implies the line does not intersect the circle at all. There are no points of intersection. Well, it could have been, I'll see now, it could have been another way of round. See now what I do here. Now see here, suppose I take up say x square plus y square plus 2gx plus 2fy plus c equal to 0. Again I must tell you here, what is the center of the circle? Let me take up a bigger case now. C center is equal to minus g minus f. What is the radius? Come on quick, shabash. Radius is equal to under root of g square plus f square minus c. Now let this line, I'm talking about this line to be what? Lx plus my plus n equal to 0. This is the line AB. I may take up AB line over here. And Cn is the perpendicular. Can you tell me what is Cn equal to? I may write it as P. What is Cn equal to? What is Cn? The length of perpendicular from point C. C is this, minus g minus f. From center, yes. What is that equal to? That is equal to minus Lg minus mf plus n divided by under root of L square plus m square. Do you agree, all of you? That is the length of perpendicular from a point to a line. This is P and this is radius. Now if AB, now look here, I am taking AB to be the shape here. I am taking A1 B1 this, and I am taking, this is A1 B1, I am taking this to be A2 B2. Now in case of AB, can you tell me what is the relationship between P and R? In case of AB, very good, P is greater than R. That's wonderful. P is greater than R. In case of AB, P is greater than R. That means when P is greater than R, which we can very easily find out, P we can find out, R we can find out, we can conclude that the line does not intersect the circle. Now in case of A1 B1 which I take up, A1 B1, if A1 B1 is the line, what can you say? Yes, what is there? P is equal to R. What can you say when P is equal to R? The line is the tangent. Tangent to the circle. Clear? Now, in case of A2 B2, come on, tell me what happens. Yes, P is less than R. Very good. P is less than R. What is happening? The line is a secant. Correct. The line cuts the circle in 2 points. Now, another point that I want to do over here is that see now what I am doing here. Suppose this touches the circle, this case, when P is less than R, what happens here? When P is less than R, you can say that P is this, R is this is AB. Can you tell me what is the length of the chord? Come on, what is the length of the chord? In this special case, yes, I do. First attend to me now. What is the length of the chord now? Come on, tell me. Don't you realize that's right, square root. It is twice square root of R square minus P square. That is the length of the chord AB. That's a very convenient way of finding the length of the chord. Very good. Right. Well, this is for competition. This is more than 11th class, and we will be going to take up competitive questions next time when we discuss more problems on circles. Right. So you have learned that how we find the condition for the behavior of a line with a circle. Now we take up another important point. Another important point is how to find the equation of tangent. Equation of tangent to the circle x square plus y square plus 2gx plus 2fy plus c at a point x1 y1 on the circle. That means x1 y1 lies on the circle. Can any one of you tell me what will be the equation? Now the best way for competition purposes is that we differentiate to get what? We differentiate to get the slope of the tangent. What will be? That's right, that will get slope. Correct. Can you tell me what is dy by dx equal to? Dy by dx is equal to minus 2x plus 2g divided by 2y plus 2f. That is equal to minus x plus g divided by y plus f. Correct? I have found dy by dx. Clear? Now at dy by dx, now what will be dy by dx at x1 y1? At x1 y1 will be minus x1 plus g divided by y1 plus f. And what will be the equation of the tangent? Equation of tangent will be what? Y minus y1 is equal to minus x1 plus g divided by y1 plus f times x minus x1. And that will turn out to be equal to, can any one of you tell me what shall it be? It will become xx1 y1 plus g times x plus x1 plus f times y plus y1 plus c equal to 0. This is how we get the equation of tangent. Please understand. I'll give you a shortcut how to find out this quickly. I'll give you a shortcut to find out this. Now, see now, see, whenever you have to find out the equation of tangent, try to find out, look here, this is the equation and this is the tangent. X square becomes xx1, y square becomes yy1, x becomes x plus x1 by 2, y becomes y plus y1 by 2, constant remains same. That is how you get the equation of the tangent. Please understand it. That is, what are the equation of tangent? What are the equation of the curve? X square plus y square plus 2gx plus 2fy plus c equal to 0. This is the equation of the curve. Now how to find the equation of tangent? Equation of tangent. Apply this rule over here. Apply over this rule. Equation of tangent at x1. It becomes xx1. Y square becomes what? Y square becomes y1. Y square becomes y1, and 2g into x becomes x plus x1 by 2. 2f y becomes y plus y1 by 2, and constant remains same. That becomes what? xx1 plus yy1 plus g times x plus x1 plus f times y plus y1 plus c equal to 0. This is how I find out the equation of the tangent. Also, I must tell you here, how did I find dy by dx? I have told you how to find dy by dx. Dy by dx can be immediately found out by differentiate with respect to x, differentiate with respect to x, and divide by the differentiate with respect to y. Differentiate the given equation with respect to x only, keeping y as constant. Keeping y as constant, differentiate this equation with respect to x. You get 2x, y square will be 0, 2g. That you get as minus times 2x plus 2g. And differentiate with respect to y, you get, taking x as constant, you get 2y plus 2f. That is what I told you. Okay, that gave us minus x1 plus g upon y1 plus f at x1 y1. After this, what will be the equation of normal? Equation of normal will be obtained by what? The slope will be reciprocal, negative reciprocal of this. So I write here equation of normal to be normal. Y minus y1 equal to y1 plus f divided by x1 plus g times x minus x1. This is how I find the equation of normal. Right. We stop here. Next time, that is on Wednesday, we'll be taking up some important questions, very important questions, just as we have done questions on complex numbers last time. I had more questions, but we were short of time. but next time we'll be taking up different questions on circles. Any of you who wants a special class, should write to me on this address. I can arrange a class right. Okay. Yes, you can. But before you leave, please write down your impression, whether you support. Okay, you can give me your question. This is my mail address, and if I can give you what is the area between the chord and what? Edge of the circle. Well, that can be calculated by integration, right? That is the segment. That can be written as area of sector minus area of triangle. Okay? Area of sector minus area of triangle. Okay, thank you very much. We finish up here. But please, good evening. Gitesh, please fill up that your impressions, whether you recommend or not.